Hello everyone, this is Dr. Muneza, and I hope you all doing great. Today we are going to cover an introductory lecture of research methodology. But before I begin, I would like to commend those of you who haven't enrolled yet. They can request access to the class lectures via e-class option available on the web. So starting a lecture with a question, research is it an aptitude or an attitude? So when you think about research, there are a series of questions like what's the need of it? Do we all need to indulge ourselves in it? Why should I learn research methodology? But coming back to the first question I ask you, is it an aptitude or an attitude? If you ask me this question, I would say it's an attitude, because you need to do a little bit of research in your day-to-day task, from investing in a business, choosing a partner or a clothing brand or a vaccine that suits your body. And in case if you're marketing or sales, understanding consumer behavior, they all require exceptionally good research skills. And those who don't have good research skills, they suffer from financial loss and they go through this physical and emotional pain. So research is technically an attitude of foresighted individuals who are concerned about long-term benefits before making any decision. So it's an attitude that comes with motivation, and your motivation defines your aptitude for it. So if you are into research thing, you need to find out first, what's your motivation? Ask yourself this question before embarking this holy journey. Why am I getting a research-based degree? Is it because I want to be as cool and popular as Einstein? Or is it because I just want a degree to get promotion and pay a raise? Or is it because I want to contribute something to the society? A few days ago, I asked this question and created a poll. What's your research motivation? And I was actually excited to see that 58% chose innovation. 30% chose sustainable solutions, leaving behind 12% falling in the trap of short-term benefits. Let me tell you something. Your motivation is the key, and it defines your research outcomes and the impact that it's going to make. So if you're into research for promotion and popularity or just to earn a degree, it simply means you don't have the right research attitude, because it requires resilience, patience, and creativity. And if you have short-term benefits, you will never be able to do a real research. You will just scatter and fail miserably in the end. So your motivation gives you the right attitude. And let me tell you an interesting thing. You can predict your future in your research career because it's a function of your aptitude and willingness that comes from your research motivation. So if you're a person who sees a problem and think and find a solution, you can be a good researcher, you know? But if you're a person who sees a problem as an opportunity, bingo, you are going to be an excellent researcher. In case if you're a person who does not see a problem at all, you are not fit for research. And if you see a problem, but you have no idea how to find out a solution, you're more likely to be a mediocre researcher. So your attitude reprograms your aptitude and ultimately defines your future as a researcher. So here's a future based on motivation that defines your aptitude and willingness. In the first quadrant lies those who think they can find a solution of a problem. They have good aptitude, but low willingness to make an impact, so they just continue to discover new things. Highly motivated researchers drive knowledge economy, and they are in the second quadrant. They have the right combination of aptitude and willingness to find an opportunity in any problem, And they are actually the ones who create business from their research work and make huge socioeconomic impact. Those who don't see a problem, the cool guys, they're not fit for researcher and they lie in the third quadrant because they neither have aptitude nor willingness to identify a research problem. And the fourth quadrant lies people with short-term goals. They are the ones who come up with irrational research design, which is neither innovative nor sustainable. They don't care about impact once they are done with their degree promotion thing. So if your goal is big, you want to do something new, creative, or simply innovative, bingo, you got the right attitude. You're all set to go. Let me ask you a question. Do you think you've got an eye to see a research problem? Yes? So when do you know that you have got an eye to see a problem? It's exactly when you start feeling that there is something just not right. Then you start realizing that something can be done in a more better way. In 2017, I was asked to teach a course of polymer engineering to a class of chemical engineers. I have this habit of doing a little bit of research before I start doing anything, like I said in the beginning. So I asked senior students about common difficulties they face when they go to industries for internship. They said we find it hard to implement theoretical knowledge acquired at campus and correlate it with the industrial problems. So I came up with the idea of including a real life problem in the start of lecture to help them correlate while we are studying this specific course. And I included this picture and I wanted to get their perspective from chemical engineering point of view, what possibly could have gone wrong in this picture. So it's basically a tire burst and an accident that took place somewhere between Dubai and Abu Dhabi at E11. And basically a military truck was transporting refrigerated goods from one city to another. So there were additional stresses considering the environment in which the vehicle was moving, like long trips, heavy loads, high speeds, high temperatures. And I wanted to motivate my students to think that how simple molecular structure and engineering the molecular structure of a polymer affect its operational efficiency, and it makes a huge impact, as you can see over here. So if you choose the right blend, you can actually achieve good performance, tire performance under the given extreme conditions. So this is another research problem, and it's basically from the course that I've been teaching, Diagnostic Imaging. So on your left, you see the computed tomography images that were acquired back in 80s. And on the right, you see the one with the good resolution and contrast. You see the images being acquired nowadays. And I want you to do a little bit of brainstorming, those of you who are biomedical engineers. What possibly were flaws in the CT scanners back in 80s? Can you identify? Let's pause over here and think. Well, if you have identified the flaws just by looking at the picture, and you can figure it out how the advancement has taken place over the past few decades, you can be a good researcher. And if you fail to do so, you need to go back and revise your courses. So computer tomography is basically an imaging technique to see the inside of your body, and it images 2D slices of your body through X-rays. And there is a detector, and there's an X-ray tube that rotates around a gantry, and the table has a patient that goes through the bore of the machine, and it creates 2D slices, and then you reconstruct the image to get what it looked like this now. So this is a timeline of evolution of computer tomography scanners. So back in 80s, you were able to acquire images of single organ, as you see here. And now you're able to have a detailed picture of multiple organs. So there was a low coverage, poor resolution, both spatial and temporal. And now you can see the resolution, both temporal and spatial. It has improved a lot. And it's basically because of the technology that has evolved. And the reason why I've included this, because I want you to identify the flaws back then, the problems, right? The flaws are the problems, and how researchers have worked really very hard to get the image quality that you see today. So it's not just something that happened so quick. There were decades of research that brought improvement in the technology. So in conventional scanners, the mode of scanning was translation and rotation, which we call sequential scanning. The inclusion of slip ring technology, which allows continuous motion of X-ray tube and detector as your body is scanned. This actually helped improve the resolution and the number of the slices that the X-ray tube scans. So this is an illustration of sequential CD and helical CD. So sequential CD, actually, it takes discrete slices. In helical CD, because slip ring technology allows continuous motion of gantry, you can acquire continuous slices in a spiral, scanning mode. So the images that you get are more detailed. And then the detector technology was improved. And in the conventional scanner, there was this one long detector about 8 to 12 mm. And now the size of the detector has been reduced considerably to 0.25 mm. And the number of the detectors that you can have in a row, it varies from 4 to 128. So the number of the detectors you have affect the thickness of the slice, and it ultimately affects your image quality. So, and now we've got this concept of pitch, because in sequential scan mode, the patient table was kept stationary. Now, in a spiral mode, there's a thing called table feed, and this defines your pitch. That is the movement of the table per rotation, its distance divided by the width of the collimated beam. So you can see the difference when you change the table feed per rotation and the collimated beam thickness. So especially how the slice is gonna look like. The slice is obtained gonna look like. So if you take a look at this figure again from left to right, the pitch has been considerably improved in the new models of CT scanners. So this allows you to have a wider coverage with increased spatial as well as temporal resolution, and gives you a better contrast of soft tissues and the bones. Now, there is another thing that I would like to highlight. There's a dual source scanning now, because you're scanning through X-rays. So now you can use X-rays of two different energies, low and high energy. And there are different variants of dual source CDs. Now you have dual source CDs with dual layer scintillators, and this technology was introduced by Philips. And basically you have a sandwich scintillator in your detector, and the first layer absorbs the low energy and the second layer absorbs the high energy X-rays. So within one detector, you can detect both types of sources of X-ray that you are using to produce image of human body. So, and this is actually the type of the scintillator I was talking about in my podcast, using nanocrystal QDs and in your scintillators. So the point of including this entire problem, how image quality has been improved over the past few decades, it's an extensive work of researchers working in this domain, diagnostic imaging, and it's very interdisciplinary. So it's the CT scanner with this good contrast we see today is basically the outcome of the extensive research work done behind over the past few decades. This ultimately improves, the quality of patient care you received. So what happens when you're not familiar with research methodology and you embark this holy journey of doing a research work? You reach a dead end, and that's the end of your research career. If you don't know the right method, if you don't know the right tools, how to use it, if you know the tools, but you don't know how to use it, you will reach, at some point, you will reach a dead end. You won't be able to conclude your findings. So this course is designed to help you understand the best practices in research, to help you, get training of the tools that are required in your research work, the techniques used in data analysis, the ethics you might want to consider, and the communication mode once you are successfully done with your research study. So with this, I wrap up this introductory lecture, and I hope to see you in the next lecture. Thank you.